Lesson 2, Uniform Motion, Speed, Velocity, and Position Time Graphs. Uniform motion is the movement at a constant speed in a constant direction. So there are two components to uniform motion. Number one, the speed is constant, and number two, the direction is constant. If any one of these change, then what you have is non-uniform motion. Non-uniform motion is the movement that involves changes in either speed or direction or both. Let's look at the first quantity, average speed. Average speed is defined as the total distance traveled divided by the total time traveled. It's a scalar quantity, so we know that there won't be any direction associated. The equation is average speed is given the symbol lowercase v. This comes from the Latin term velocità, which means speed. So v is equal to delta d over delta t. Delta d, we learned in lesson 1, means distance. And delta t means how much time has passed, or the elapsed time. So speed is equal to distance divided by time. Before we do an example, let's define instantaneous speed. This is just an object's speed at a particular instant in time. And it too is a scalar quantity. Let's try sample problem number 1. In 47.8 seconds, a sprinter runs 400 meters. What is the sprinter's average speed? So we're given two quantities, 47.8 seconds is the elapsed time. Make sure you write down everything that's given and use the proper symbol to denote what that quantity is. This will help you decide which equation to use. The second quantity is 400 meters. So we have a unit of measurement, which is the meter, and there's no direction, no reference point. So this must be a distance. So in this question, they give us distance and elapsed time, and they want us to find the average speed. So average speed is equal to displacement, or distance rather, distance divided by elapsed time. We can use the equation up above for speed, and we can sub and solve these values in. The distance is 400 meters, and the elapsed time is 47.8 seconds. If you punch this into your calculator, 400 divided by 47.8, you should get 8.36. Now, what will the unit of measurement be? Whatever you do to the numbers, you must do to the units as well. So if you're dividing 400 by 47.8, then you're dividing meters by seconds. And that ends up being the units. So the speed is 8.36 meters per second, or we can round this to 8.4 meters per second. Let's define average velocity. Average velocity is defined as the change in position divided by the change in time. And it is a vector quantity. If you look at the equation, it kind of resembles the one for speed above, except that this quantity has an arrowhead on top of it, this arrow, which implies that it's a vector. Delta D with an arrowhead on top, if you look at lesson 1, means displacement. And delta T means elapsed time. So velocity is equal to displacement divided by elapsed time. Let's try an example. The world's fastest coconut tree climber takes only 4.9 seconds to climb 9 meters up a coconut tree. Calculate the climber's average velocity for this motion, assuming that the climb was straight upward. So we're given two quantities. 4.9 seconds is given, and that is the elapsed time. Make sure you write down both the symbol, the quantity, and include the unit as well. The second piece of information that's given is 9.0 meters up. Our unit of measurement is the meter. We have a direction up, so this must be a displacement. A displacement has both the unit and a direction and no reference point. Okay, now let's find out what they are asking us for. They want us to find the average velocity. So the average velocity is equal to displacement divided by time. This is the equation we just learned above. We can sub the values in. Displacement is 9 meters up. Please include both the unit and the direction divided by 4.9 seconds. If you punch these into your calculator, 9.0 divided by 4.9 seconds, you should end up with 1.8 meters per second, and you have to include the direction as well. So the velocity of the world's fastest coconut tree climber is 1.8 meters per second up. So we've looked at the motion of an object using calculations and equations, but we can also visualize the motion of objects by plotting graphs. The first type of graph we're going to look at is called a position time graph. It's one that tells us our position on the y-axis and our time on the x-axis. So here we have an object moving forward, and we can see that there's a pattern formed here, that this object is traveling at a constant rate. And we know it's a constant rate because it's producing a straight line. If you have a position time graph, there's important information that you can gather from a position time graph, and that is the following. This line is sloped, and the slope of a position time graph gives the average velocity of the object. So if I can find out the slope or how steep this graph is, we can find out the velocity of the object. So slope is something you learn and study in mathematics, and it's defined as the change in the y-axis divided by the change in the x-axis. So what we're looking at is the rise over the run. You can pick any 2 points on a position time graph to calculate the slope. I'm going to choose the point 5 meters in 4 seconds, which is here. And I'm also going to choose 2.5 meters in 2 seconds. If we calculate the rise, how much it increased from this point to this point, and divide it by the run, how much it increased from 2 seconds to 4 seconds, we can find the slope of the line and therefore find the velocity of this moving object. So the y-axis is measured in position. So when we're finding delta y, what we're really finding is the change in position delta d. And when we're finding delta x, since the x-axis is measured in time, what we're finding is delta t, the elapsed time. Delta d divided by delta t is the equation for velocity. So we can find the velocity by finding delta d divided by delta t. Delta d means the final position minus the initial position over final time minus the initial time. So this is the initial. These 2 points here, we have distance and time. This is our y-axis, this is our x-axis, and this here is our final. So our final position is 5 meters forward minus our initial position was 2.5 meters forward divided by our initial time was 2 seconds, our final time was 4 seconds. If you simplify this, 5.0 meters forward minus 2.5 meters forward, keep in mind that both of these are in the same direction, so we can proceed algebraically and punch these two values into our calculator. 5 minus 2.5 is 2.5 meters forward. And 4.0 minus 2.0 seconds is 2.0 seconds. If you punch this into your calculator, you end up with a slope of 1.3 meters per second forward. So our slope, and hence our velocity, is 1.3 meters per second forward. This position time graph with a straight line that is sloped upward tells us that an object is moving forward with a constant velocity. Let's take a look at a different position time graph, which tells us a different story. This is a position time graph showing an object that's moving backwards. And you can see that it starts at this position, 10 meters, and the object is going over time closer to the start, 0 meters. What you want to do is find the average velocity, and we can find the average velocity by finding the slope. So the slope is the change in y over the change in x, which is delta d divided by delta t. Final minus initial over final minus initial. Pick any 2 points on this graph. You can literally pick any 2 of these blue dots. What I'm going to pick is the point at 4 seconds, which has a position of 5 meters east, and the point at 2 seconds, which has a position of 7.5 meters east. Okay, so this is our initial, and this is our final. So our final position is 5.0 meters east minus our initial. So this is our final. Our initial is 7.5 meters east. Divided by our final time was 4 seconds minus 2.0 seconds. So let's simplify. We can subtract these using our calculator because they're in the same direction. We have 5 meters east minus 7.5 meters east. If you punch this into your calculator, and remember, always use your calculator, even if it's something simple, because it'll help you to make sure that you don't lose any grades or marks by carelessly guessing in your head. If you punch this into your calculator, you get negative 2.5 meters east. And if you do 4.0 minus 2.0, you get 2.0 seconds. So our slope, if we calculate it, will give us the average velocity. We have negative 2.5 divided by 2.0. We end up with negative 1.25 meters per second east. Now, what does it mean when an object has a negative velocity? Well, a negative velocity means that it's traveling in the backward direction. Now, we can actually rewrite this. We can make this a positive. We have a negative sign here in the east direction, but you can change the direction of a vector by changing its sign. So instead of writing negative 1.25 meters per second east, we can change the sign to positive, which will change our direction to west. So change the sign, change the direction. And this makes more sense. Negative 1.25 meters per second east tells us that the object is traveling backwards. Backwards from east means the object's actually traveling in the west direction. I would like you to try the homework practice questions at the bottom of this note. When you are done, there's an LMS quiz that you need to complete as well. Good luck.